بسم الله الرحمن الرحيم. نرحب بكم جميعا في يومنا الثاني من مؤتمر الإدارة الصحية الثالث، ونستكمل جلسات المؤتمر. سنبدأ الآن مع الجلسة الخامسة من مؤتمرنا، وهي بعنوان الذكاء الاصطناعي. فليتفضل المحاضرين على المسرح، وهم الدكتور فيدريكو بيلغاس، الدكتور سيلفاتور سيلفيو، السيدة مولي فينال، السيد هاميش كلارك، والدكتور سكوت نونسون، ورئيس الجلسة الدكتور علي الزيلعي. رئيس الجلسة الدكتور علي الزيلعي، وهو دكتوراه في أشعة المخ والأعصاب من جامعة كونزلاند بأستراليا، ومستشار الأبحاث بوزارة الصحة، ورئيس اللجنة العلمية لعلوم الأشعة بالهيئة السعودية للتخصصات الصحية، والأستاذ المساعد غير متفرغ بجامعة الأمير سلطان بن عبد العزيز، ورئيس الزمالة السعودية لتقنية الأشعة، وعضو لجنة الاعتماد المؤسسي والبرامجي بالهيئة السعودية للتخصصات السعودية. دكتور علي، تفضل، الميكروفون معك.
السلام عليكم ورحمة الله وبركاته. And before we start, I'd like to welcome all our speakers. Salvatore, please come on the stage. Federico Bolges, Molly Final, Hamish Clark, and finally Dr. Scott Nowson, please come on the stage. Yes, please. Thank you very much. First of all, I'd like to give a bit of introduction about artificial intelligence. Artificial intelligence, or machine intelligence, has many applications in today's life. The form of AI described as programs developed to perform specific tasks that's being utilized for a wide range of activities, including medical diagnosis, electronic trading platform, robot control, and remote sensing. AI has been used to develop and advance numerous fields and industries, including finance, healthcare, education, transportation, and more and more and more. So today, we are fortunate this morning to have a collection of AI experience. The journey will take us for about 1 hour, 20 minutes, starting with the fundamental of AI and its application in healthcare administration, moving to a real experience in Saudi Arabia, which is the Clinical Command Center in the Ministry of Health, then ending with the future of AI in healthcare. Our first talk, titled Fundamental of AI and its Application in Healthcare, going to be presented by two speakers. Number one is Silvio Salvatore. He is Managing Director, Direct Export Countries and Latin American at AGFA Healthcare. His qualification in clinical engineering, in chemical engineering and pharmaceutical. He is expert in statistics, intelligence solution, medical device, quality system certified, working in healthcare for the last 25 years, managing and participating in the transformation from analog to digital technology. He is ITIL certified. His colleague in the same presentation is Federico Bolgas. He is a business development manager at TSI Group. His qualification is in biomedical engineering and management of public health care provider. He is expert in project manager and the delivery of solution for digitization of data from clinical laboratory, such as pathology, dermatology, gynecology, and obstetric. The second talk is Clinical Command Center, where AI meets human action. So this will be a practical example of how we apply AI to our healthcare system. Molly Final going to present this title. She is leading the Clinical Command Center for emerging growth markets on behalf of GE Healthcare partners. She joins the region working with the Ministry of Health on the first healthcare command center outside of North America. She has delivered programs with hospitals, government institutions, buyer, and regulators to improve healthcare delivery across 5 different countries. The final talk will be entitled with Fit for the Future. So AI driving innovation and healthcare transformation. The 2 speakers is Mr. Hamish Clark. Hamish is he leads the PwC healthcare industry practice in the Middle East, and he is over 20 years of consulting experience. His core experience is in strategy and operation for transformation, cost reduction, efficiency and productivity engagement with hospital and health systems. Hamish also leads PwC digital upskilling program for consulting. The final or the last speaker today will be Dr. Scott Nawson. He is artificial intelligence lead in PwC Middle East. Scott, after completing his PhD at the University of Edinburgh in natural language processing, which is NLP, Scott spent about 14 years working in artificial intelligence. So we are proud to have him today with us. In advanced analysis and data science, he joined PwC and moved to the Middle East from Europe to lead the artificial intelligence team applying AI across industries, including and within healthcare. So we'll start with the first 2 speakers, please. Silvio and Federico.
Thank you. Hello, good morning to everybody. Thanks to be here. And as said, we are going to mention or to comment about artificial intelligence experience that AGFA and TESI developed in the last years. And I would like to start just from the why artificial intelligence. Probably the answer to these questions is different or different point of view, different corners approach. In our case, in the case of our companies, the idea of artificial intelligence is to answer to some needs that is not just born, but the needs of radiologists, of professionals, of medical doctors, scientists, to have some help from the technology, from the evolution of the tools. It's something that is not born today, is not born yesterday, but is since many years with the evolution of the PC and the system of elaboration data. We started years ago talking about statistics, so to apply statistics to the prediction of epidemiology or to the prediction of some diagnosis based on the technology that was years ago. But not only the statistics, there was also the neuronal activities and the networking. There was a lot of mathematical approach to do this prediction, but all these activities, all this approach needed competencies in statistics or in mathematics, so competence that is a bit far from the competence of a radiologist or a doctor. For this reason, and also a lot of help from the performance of the computer to elaborate all this data. But then, with the complexity increasing, with the number of data increasing and available in the study or in the activities of professional radiologists or doctors, the approach of used in the past is not working anymore. There was a transition before between the previous approach, so the statistics, the neural networking. There was in the middle, between the artificial intelligence, there was the CAD, mentioned also computer-aided diagnosis, that should help the radiologist, but not only to make the diagnosis. But now, even with these tools, with the computer-aided diagnosis, this is not enough, because the number of data, we talk pretty often about the big data, all this data together, the interconnection of this data cannot allow anymore to use methodology like the one in the past. If you want to take advantage of this methodology, we have to move to something else. And this something else, is okay? Okay. Are you able to hear me? Yeah? Okay. The complexity, and the number of data cannot be faced with the same approach of the past. That's why artificial intelligence. Artificial intelligence is based on algorithms, but for the user, he not necessarily has to know what there is behind artificial intelligence. He's a user, and as a user, he has all the advantage of using this tool, but without having all the necessary competence to develop the tools or the necessary competence in mathematics or in statistics to be able to cope with this technology. So saying that, and maybe our colleagues in the next presentation will have their view on artificial intelligence, let's see that one of the claims that we have is that artificial intelligence is not intended to replace people. So maybe we will need some improved competencies in some areas, but it's not intended to replace people, but is intended to improve the quality of the outputs, to improve the efficiency of the organization. And for example, in the case of radiology, you can imagine when, with the new technology, you have a significant increase of examination requests, even because it's increased the request of healthcare in different countries. So there is a continuous evolution in the technology together with an increasing of request of examination. So how an organization has to be prepared in having the right resources in the right place, the right numbers, and in the right moment. Let's think if we have an epidemic of some disease, as it happens in the past, how we can be, or some disaster, like an earthquake or things like that, how can be an organization able to predict the number of people and the number of resources in an efficient way. And all this has to take into account that all the projects, all the program has to be, from the financial point of view, sustainable. Otherwise, it's useless to have a beautiful system if they are not financially sustainable. So, saying that, what we have done in the last period has been we focus on some activities that are part of our sector of activities, that is diagnostic imaging, together with, in particular, with the radiology, and a lot of vendors, or most of the vendors, are approaching the same topic. There is really an increase of companies in the last RSNA in Chicago, that is the Congress for Radiologists, the most important in the world. In Chicago, there was an entire area dedicated to artificial intelligence, applied in the different fields of of the medicine and, in this case, of the diagnostic imaging. So to move to some example of what has been done in the last period, I can mention two approaches that we are following. The first one, that is already a reality, was an experimentation that we have done with the Dubai Healthcare Authority, and the topic was how we can manage the increased demand of diagnosis for TB. As with the movement and the mobility of people among the different continents about the different regions, often we see in some regions an increase of TB. In the case of DHA, the Medical Fitness Center, that is the organization created to check and to screen the people arriving in Dubai for work, typically, there are some of screening that are mandatory. One of these screening mandatory in Dubai is the screening of TB, because the high invasivity and the high risk to create an epidemic. For this reason, every day is calculated that there are, roughly speaking, 5,000 examinations, chest examination to identify TB, TB positive or negative. And you can imagine in this medical fitness center spread all over Dubai how the radiologist has to cope with all these requests of examination in a reasonable time. And the result was that the reports and then the diagnosis, if the request can be approved or not, or if treatment are needed, has to be done in a real time. About 5,000 of examination requests, that is pretty difficult. So the answer was to test and to verify artificial intelligence in this area. So basically what has been done a preparation work where every case has been managed by the radiologist as usual, but in the meantime we give this data, the output, the quality of the image, the data of the image, the type of pixel that we are talking about, to the algorithm developed to identify exactly the presence or not of a signal of TB. So what has been done was to provide a lot of data that we separated between positive and negative, and the algorithm start to elaborate this data. The more data we provide, the more increase the two most important value when we talk about artificial intelligence in diagnosis, that is the sensitivity. So how many cases we are able to detect as positive out of 100 positive cases, and we are here about more than 90%, increasing. The more data we do, the more data we provide to the algorithm, the more is increasing the sensitivity and the specificity, that is the number of negative cases versus the total number of negative cases detected by the human evaluation. So with these two parameters in mind, we have been able to verify and to accept this system in the real day-by-day work of the radiologist, meaning that the radiologist has received the information that there is a possible positive case, while the negative case are not even informed the radiologist. Once there is a positive case, then the radiologist can focus on that case and not on all the cases that are being submitted to the system. In this way, instead of having a reporting of 5,000 examination, you have a reporting numbers that is significantly decreased, depending on the case, depending on the medical fitness centers, but is significantly decreased. And that was able to remove the backlog that every radiologist, every medical fitness center has in his work list. Of course, improving the productivity and improving the quality of the response to the people waiting for an answer to be or not in Dubai. The other case that I wanted to mention is Thank you, Federico. Is one of the most critical diseases that is affecting, I think, most of the humanity, even because increasing the age, this type of pathology is increasing even more. We are talking about, generally speaking, the cancer, but in this specific case, we are talking about the breast cancer. That is the first reason of death of a woman in the age between 40 and 50. So it's extremely, extremely sensitive topics. The map that you see here is how the cancer, breast cancer, has been predicted in the different parts of the world. As you can see in the red area, we have a very high predictability of cancer thanks to this earlier diagnosis. In the area lighter, like blue light, is not that there is no this effect of breast cancer. It's because the screening activity is less diffuse than in other countries. Breast screen activity is something that started at the beginning in North Europe and then spread all over the world, and now also Middle East is increasing the number of processes and procedures to identify earlier the breast screening. Okay. And this is some qualitative information about the breast cancer effectiveness activities progress that we have in our world, in our healthcare. And in the past, the expectation of survival of a woman when was predicted a cancer was pretty low, below 50%. Nowadays, in average, above all in the US, we reach 86% of probability that the patient will survive within the next 5 years. And probably, or unfortunately, most of us have some relatives that was affected by breast cancer, and I'm sure and I hope that most of them have been successfully treated thanks to the early diagnosis. And in this case, the need of the AID, of artificial intelligence, is not only to increase the productivity, is not only to increase the fast answer that you have to give, is the capacity, the capability to mix data arriving from different sources. In the past, there was just the analog mammography, not easy to identify micro calcification. Then there was the digital mammography that increased, but now with the tomosynthesis, that is a technology that can provide you 10 times the information that you can get with the normal mammography, digital mammography, and thanks to the MRI mammography and the echography mammography, and so on, the number of data to predict and to diagnose the breast cancer are really, really a lot. And in order to have quality of the response, you need the help of artificial intelligence that can mix and match all this data coming from different modalities. Federico, I leave you to
Okay. Thank you so much. Good morning, everyone. So I'm going to start from the beginning, just try to understand what is artificial intelligence and why we need artificial intelligence in healthcare. I'm going to be quick in this part because I think that more of these points you know already. And then we are going to see some real applications, specifically in pathological anatomy, digital pathology, and then in endoscopy. So what is artificial intelligence? I think that this sentence could explain very well what is the idea of artificial intelligence, when we suddenly know what we don't know. So specifically, artificial intelligence is something that is able to give us new knowledge or a better knowledge, so improve what we know about something. This could be one of the main definition of artificial intelligence. Artificial intelligence is a collection of advanced technologies that allow machine to sense, comprehend, act, and learn. So using machine, we are also able right now to improve our knowledge. If you're going to Google artificial intelligence and you put, for example, spending, or you put money or other words related to the money, you're going to see a lot of these articles. For example, worldwide AI spending to hit $35.8 billion in 2019, or artificial intelligence in healthcare market, size worth $8 billion by 2026. Or Asia-Pacific spending on AI systems will reach $5.5 billion this year. Then again, artificial intelligence software market to reach $118.6 billion in annual worldwide revenue by 2025. So as you can see, right now we are spending a lot of money regarding artificial intelligence in different areas. And we are going to spend a lot in a few years and in the next 10 years. We can find artificial intelligence in many areas, as I told you before: nanotechnology, robotics, security, space equipment, energy, or specifically regarding life science industry, medical education, microbiology, healthcare, biopharma, biology, biotechnology, or histopathology. So which are the goals of artificial intelligence? Specifically are two, and you can easily understand it. The first is creating expert system. So something that can display intelligent behavior, learn, demonstrate, explain, and provide the users with the best pieces of advice. So something that can useful for us to improve, specifically, for example, in healthcare, diagnosis, for example, or the treatment of the patients, and so on. And then the next goal is implementing intelligence in machines. So it's all amazing. Yes, it's all amazing, but we have to think about that there are also barriers or some problems, or we can say some doubt about artificial intelligence. The first of all, the fact that the integration of data is complex. We are speaking about of different data. Speaking about healthcare, we are speaking about of the management of images, management of numbers, management of text, and so on. Also, the amount of this data is going to be really huge. Then another challenge is the trust and liability issues related to all the data of the patient, of the cases that we are going to elaborate. Of course, you have a lot of data, so you are going to need a huge infrastructure to manage this type of applications. Of course, you are going to have a high cost of implementation. It's really important also the fact that there are specific skills that we know to understand to be successful in AI, artificial intelligence solutions. Specifically speaking, in healthcare, there are some problems or doubts that we have to underline. The first, the fear of job replacement. It's not a real problem, but it's a fear that we have. Less human interaction and affectionate care, you can understand why. Data privacy. Also, the problem of the implementation of new technology that is going to change the way in which we are working right now in many areas, specifically in healthcare. The development cost, and then the cybersecurity. So we have seen that we are spending a lot of money. We have seen that artificial intelligence is something that could be really good, but we have some doubt about this implementation. So why we have to implement artificial intelligence in healthcare? This sentence can explain the reason why. AI applications are designed to address specific real-world use cases that make the diagnosis, monitoring, and treatment of patients more efficient, accurate, and available to population around the world. So we are going to use artificial intelligence because we want to improve the quality of care for patients. This is the reason why. Here you can have a list of all the pro regarding artificial intelligence in healthcare. The first, the better data-driven decision. We can increase the diagnosis efficiency. We can cut the treatment time, or also the integration of different type of information that can be really useful to achieve, to arrive to a better diagnosis. Then reduce unnecessary hospital visits, because, for example, if you are going to use this type of solution for the screening, you are going to reduce, of course, the hospital visits of the patient, because you are able to understand before the disease that the patient can have. And then create time-saving administrative duties. So all these points are in a way related of what we know that is present here in Saudi Arabia, is this Vision 2030. Other important thing that we have to underline is that using AI application in healthcare is really good to improve the quality of care, but it's also good because we are going to save money. Specifically, this is an Accenture analysis. They have seen that using AI application can potentially create $150 billion in annual saving for the US healthcare economy. Here in this table, you can see the different AI application and the amount of money that they are going to be able to save until the 2026. So it's good for the patient, but it's good also for, I can say, for the healthcare system. So let's see immediately some practical application. First of all, in anatomopathology, and then in endoscopy. Here in this slide, you can see that we are working in AI applications in anatomopathology since the 50s. But only in 2018, the FDA permits the first medical device using AI to detect diabetes, retinopathy in adults. So it means that we needed a lot of time to arrive to something that could be great and useful to be implemented. Right now, in pathological anatomy, we can have two different methods to use it. The first, to the left, is studies by Google. In this study, they have tried to implement artificial intelligence solution for pathological anatomy in real time. So the pathologist, using the microscope with a specific slide in the tissue, is able to directly, in real time, see the area or underline the area of the disease, the specific area of the tissue. Another method is the right one, the most common in the market right now. So the possibility to scannerize the image, so have a digital slides, and so send these digital slides directly to an AI application that is able to elaborate in some seconds the image. It can give you, as a result, what you can see here. This is an example of automatic recognition of Helicobacter pylori in gastric biopsy. As you can see, the system automatically can detect the area of the tissue that could have that specific disease. So, which is the approach of this type AI application in pathological anatomy? They are able to recognize objects, first of all, but also they are able to predict disease diagnosis and also prognosis of treatment response. It's enough to buy an AI application in pathological anatomy. I mean, you have your workflow and you buy artificial intelligence application, it's enough. Unfortunately, no. Why? Because what you need is an LIS-centric approach, Laboratory Information System for Anatomopathology centric approach. Why? Because first of all, you have in the market a lot of AI applications, and each one is specific for a specific disease. One can, for example, be able to elaborate slides only for the, I don't know, cervical cancer. Another one only for vaginal cancer, and so on. So for these reasons, you need something in the middle that can, In the middle, that could be able to acquire all the information for all the different AI applications. This is an example of a digital reporting station. As you can see, it's really similar to the radiology one. I mean, to the left, you have the LIS system with all the tray, the digital tray with all the slides. And to the right, you can see immediately the viewer of the AI application with the slide in different area. So there are, of course, some pro using AI application in pathological anatomy, but also some challenges. Like, for example, the fact that the tissue are really different in a patient than in another. And also, the same disease could have a mutation. Then the dimension of the slides. One slide usually weight 1 giga, so it's a lot of data. And then also, as I told you before, the fact that you need specialized solution. Which are the opportunity? We can reduce time for diagnosis, increase accuracy and precision, and also the automation. This is an experience that could be interest that we have implemented in Catania, the first fully digital pathology laboratory. They are using right now prostate cancer detection and Helicobacter pylori detection AI solutions. They are in progress to implement also the detection of metastasis in lymph node. Right now, they are doing more than 220,000 of digital slides, so a lot. Last point that I wanted to underline really quickly is the endoscopy. Online, you can find a lot of studies regarding endoscopy. Specifically here in these slides, you can see that only in more or less 1-2 years, the number of studies regarding AI application in endoscopy has decreased a lot in a different area and for specific applications. This is a studies regarding the possibility to identify polyps in real time. And in these studies, they have, like results, have an accuracy of 96%, so a lot. As you can see here, I think that this graph could help to understand the results. The first column is the number of polyps detected from the original endoscopist. The second one from a second expert endoscopy, and the last one detect the number of polyps detected directly with an artificial intelligence application. As you can see, the number is
You
really
have 2
high.
minutes, Federico, 2 minutes.
Okay, I have only 2 slides and I've finished. Speaking about the strength, of course, we are using this type of solution to improve the quality, improve also the detection and characterization of chronic lesions, and of course we have a lot of space of improvement. Speaking about the limitation, one problem is the need of high quality procedures, because using this type of solution, as I told you before, it means that we are going to modify the workflow in a way or in another, and also all the rules that are present inside the workflow. Then, need of cost-effectiveness validation, and legal and regulatory doubts and reimbursement, we have already told before. A case study, why using this type AI solution for the detection of polyps could be really useful. Could be really useful, for example, for the screening of colorectal cancer. Why? Because right now the number of patients, women and men, that are affected of this type of disease are increasing a lot. So be able to detect this type of polyps at the beginning could save, first of all, a lot of lives and also a lot of problems directly for the patients. I think that I'm completely finished, so it was just an example of speaking about endoscopy and ready. Thank you so much.
Thank you, Silvio and Federico, for your presentation. And before we move to the second presentation, I'm a bit worried actually, because these guys told me that robots going to replace me one day. So we'll see what will happen at the end of the session. Next presentation, Clinical Command Center, where AI meets human action, by Molly Final.
Good morning. Command centres have existed in various different industries for over 50 years. And some of these you will be very familiar with. So on the top left here, you can see a common version of a command centre. This, of course, is air traffic control. And on the top right, the most famous command centre in the world. Does anybody recognise this command centre? Of course, this is NASA Mission Control. And on the bottom left, continuing with the theme of the transport industry, this is the London Underground. And on the right, a much more recent command centre, and one which you might not expect. This is Facebook's command centre. And Facebook used their command centre to recognise fake news on their platform during the time of the US general elections. And at the 2018 AI Global Summit, Steve Cheon, the head of AI at NASA Laboratory, recognised the need for us to start integrating AI into all command centres. And when he spoke about all command centres, he spoke about healthcare. And he said, healthcare needs a way to make sense of our explosion of data. We have an explosion of data in healthcare, and we need to use it in a way that helps us to understand our patients. So why? The average hospital has 700 beds. It serves 850,000 residents and undertakes 500,000 outpatient appointments every year. It employs around 2,700 members of clinical staff, not to mention, of course, all of the non-clinical staff. And it runs over 45 different departments. Every year, the average hospital undertakes 72,000 surgeries. And it doesn't take a mathematician to see that that equates to complexity of extreme measures. One single hospital site contains millions of moments of care every day and every night. Millions of moments of care every day and every night. For us to be able to understand how to manage this, artificial intelligence gives us a platform. And I'm going to play a short video to demonstrate how. We see command centres as working in 4 ways. They function as an air traffic control, synchronising and predicting activity, providing situational awareness across the health system. They act as the conductor, helping people to understand when they need to act and when, across the whole of healthcare. They perform as a coach, supporting caregivers to work at their very best on the front line. And they function as a goalie. They provide the backstop when human intelligence fails us. But there's something much more important to drive value from the artificial insights in a command center. There is something much more complex, certainly more variable, and by far more intelligent. And that, of course, is the people who run the command centers. This is Johns Hopkins Command Center that you can see here, and you can see there's a variety of roles, both central and mission control roles, that make the command center come to life. And that's why we say artificial intelligence and human action are what get us to driving value from the insights. And it really is a wide variety of roles, from nurses, bed management, transfers, imaging expediters, schedulers, and of course, more recently, virtual care teams. To get to human action, the tiles connect the dots across a single cross-system patient-level data model. And crucially, the artificial intelligence in a command center provides new insights by combing source data and by machine learning. An example of this is being able to comb and recognize a patient who may be at risk of readmission through various factors. It may be to do with age, previous conditions, previous treatment that's failed, doctor's notes, imaging or laboratory results. And another example of this is understanding and predicting the forecast of occupancy in a hospital. So being able to understand what the occupancy might be like, and will it be dangerously high overnight, next weekend, or next month. We think of this as a data scanner and as a brain. The engine combs, it scans and combs for messages, and we do this with surgical precision because we are looking at millions of lines of data and millions of moments of care. And from this, it interprets new insights and provides new actions to the humans that are in the command center. And this is an example of the types of insights that a command center provides. This is called care progression, and it's amalgamating from various different source systems, typically between 10 to 25 source systems in any one single hospital. And it can also do this across several hospitals. For example, Orlando Hospitals has a command center that functions across 9 different sites. Care progression becomes the work list, not only for the clinical expediters in the command center, but also for the clinicians on the front line to alert them to risks with patients in their care. And you can see here that it's alerting to patients who may have breached or be about to breach a service level agreement. For example, if your echo should be completed within a certain amount of time, but it's clear that it won't be done, the command center will alert you. It also alerts patients who may be at risk of cancellation, where you have a clear process, such as getting consent before you go to theatre, but it hasn't been done. And rather than waste the patient's time and waste the slot in theatre, the command centre will be alerting you to that very early. And lastly, and of course most importantly, care progression alerts when patients are at risk of harm, where they have conflicting things going on for them that doctors might have missed. This could be a diagnosis where a previous medication is still being prescribed and given. It could be an MRI booked where the patient should not be going into an MRI scanner. And care progression is amalgamating all of that data and providing doctors with that insight. ED status works in much the same way, and I should say that these tiles don't just use artificial intelligence. Of course, they use advanced analytics, they use various other mechanisms to provide the insights. ED status tells us right now risks and risks that might be coming. It will tell you a patient that is right now falling off the pathway or the agreement for the laboratory results. And it will tell you the patients who, for various reasons, may be likely to breach. It may be that that particular cohort of patients are always the ones who breach the 4-hour standard in your emergency room. It may be that that particular condition, age, or triage, way of triaging means that patient is likely to breach. and this is pre-post optimizer. This tile is using artificial intelligence to predict the supply and demand in preoperative process and the post-operative process for the operating room. It's telling us how we should optimally sequence patients, and you can see it's providing a guide as to how to sequence all of the patients below the bar chart at the top. It also provides a pressure score, and you may have seen this on the previous tile as well. The pressure score works on global best practice. So, for example, in the emergency room, many command centres use the Canadian NEDOC score, and Bradford Command Centre that opened this week is one of those. And it's using data from various systems, so staff don't have to go around adding up the numbers and saying whether your department is green, yellow or red. The body of evidence for why this is so important in healthcare really is growing. The Judy Ritz Capacity Command Centre at Johns Hopkins Hospital in Baltimore opened about 6 years ago now. It was the first clinical command centre in the world. The Judy Ritz Command Centre looked to other industries for inspiration, and we highly advocate of this. They looked to the Olympics, the oil and gas industries, and also city government control rooms in America to design their command centre. Critically, they started with a problem. They started problem back, thinking, what is the issue we're trying to solve, so they can really demonstrate value. They came up with 3 problems. The first one was to increase the number of critical transfers that Johns Hopkins could accommodate. The second one was to reduce wait times in the emergency room for patients who needed to get to a bed. And the third one was to reduce the number of patients who get stuck waiting for the operating room. We call these OR holds. And they wanted to prevent fragmentation in the system. They wanted to stop fractions between isolated teams, and they wanted to bring together data in 7 unique systems. And they explain data as working across a continuum. And they've recently published on this in the Joint Commission Quality and Patient Safety Journal. They see it across a continuum, from descriptive to diagnostic, to predictive and to prescriptive. And for Johns Hopkins, the results speak for themselves. Johns Hopkins originally were able to manage at a safe hospital occupancy rate of 85%. 85%, that might be a number you're familiar with. Global best practice for occupancy rate generally in hospitals. 5 years on, Johns Hopkins run their hospital safely with no more patient incidents, no additional patient harm, and a reduced length of stay at 92%. That's 7% higher than global best practice. They've reduced their ED boarding, they've reduced their OR holds, and they've increased the number of transfers that they're able to accept every year. And they're not alone. Humber River Hospital in Canada has seen great patient safety and operational benefits. A 23% reduction in patients waiting in the emergency room for a bed, an indicator that we know increases mortality. They've been able to open the equivalent of 56 beds by reducing length of stay. And Oregon Health Sciences University in Portland in the US has also seen great benefits. OHSU were able to spot and record benefits from 2 months of opening their command centre. They have managed to get a 7-to-1 return on their investment, and in year 1, they accepted 913 extra acute complex transfers. So to bring it back to Steve Chian's explosion of data, we really believe that human actors are critical in bringing artificial intelligence to life. Artificially intelligent-driven command centres prevent risk, prevent poor care, and maintain patient safety in millions of moments of care every day and every night. And as John Holden, the Chief Executive of Bradford Command Centre, the first command centre in Europe, as he recently said, in 3, 4, or 5 years' time, we will look back and wonder how we ever managed healthcare without something like a command centre. Thank you.
Thank you very much, Molly. We'll leave the question to the end of the session. So next talk will be Fit for Future, AI Driving Innovation and Healthcare Transformation by Hamish Clark and Scott Nelson.
Are we on? Assalamu alaikum. And good morning to you all. My name is Hamish Clark. I lead the healthcare practice for PwC. It's a great privilege to be here and speaking with you on AI and digital disruption in healthcare. Can I thank Dr. Khalid for this opportunity? And also, I was really impressed with this conference from yesterday. I think the society has an increasingly prominent voice in the Saudi healthcare system. There is a lot of different healthcare across all the industry here, and I think you have a really great opportunity to be shaping the debate, looking at it from a sector perspective, and being an influential voice. So thank you for this opportunity. We want to do 3 things. We'll introduce Scott as well, Dr. Scott Nelson. He leads artificial intelligence for PwC, and I lead our healthcare, so we thought it was a nice combination between us. I want to give a strategic perspective first about AI and the disruption in healthcare, and thank you to the previous panelists talking very practically about some of the innovations that the technology is bringing. Then Scott will talk through how do you start? How do you scale AI? What are some of the issues around ethics and trust? And then I'm going to leave you with hopefully a very thought-provoking challenge here in this kingdom around AI, because we think there's a beautiful opportunity for major adoption in our industry. Okay. With the clicker, do I need to go back up here? Does the clicker work? Excuse me. Let me. Oh, the clicker. Let me go here. That's fine. I'll go here. Okay, sorry. Excuse me, right. Here we go. Okay, how is AI driving transformation in healthcare? In this current decade, I'm sure, can I have a show of hands, how many people have actually got a wearable on them at the moment? A wearable device? Quite a few. Yes, very good. We can look at our heart rate. In other parts of the world, we can look at ECG, etc. And as Molly was talking about, there is a huge amount of data. Data is doubling rapidly, and in healthcare, as we hear and we know, when you run hospital systems, primary healthcare, there is a need to look at unstructured data, and AI is better than a human in that respect. There's 8,760 hours in a year, and in one specialty, one clinical specialty, dermatology, there is 11,000 journal papers published. So if you're a consultant looking for some incisive analysis on dermatology, you can go to AI and they will produce a snapshot of that across all that journal evidence. And that we as humans can't do that. We see the next decade moving into the what we call the medical ecosystem, and we think there will be a need for far greater and more fundamental partnerships with AI to capitalize on this. I think what we're seeing is some of the world's wealthiest knowledge management companies, like Google, like IBM, like Apple, they are into healthcare in a very, very big way, a substantial way, because they sit on all the data and they have direct conversations with us as consumers. And then we also see some niche players coming in to disrupt the market with AI technology. But our challenge is actually the conventional healthcare. You as health leaders in the conventional space actually partnering with AI operators to really get the best out of this technology. And then where we see this going is very much around personalized application of AI. I don't mind sharing this personal story with you, but last year at the Future Investment Conference, I had a swab of my saliva, and the results went back to My Genome company in India, and my DNA profile came back, and in that, I have a high likelihood of developing Parkinson's disease. And actually, my mother is suffering from it very badly at the moment. But what that made me think was, actually, I activated my own personal desire to look at that more fundamentally. So now there's a developing body of research around Parkinson's is actually linked to the gut. And therefore, having a good diet and keeping active is a really important part of that. And so that just shows about the personalized application of AI will be coming. We said it's all very well to have successful health companies, operators, technology players delivering AI, but 2 years ago we did some thought leadership and said, are the public ready for this? We were quite provocative and asked a number of questions across the YouGov survey of 11,000 people across EMEA, including here in Saudi. We said, would you be willing to receive healthcare in place of a human doctor? And we were surprised and shocked by the results. So you can see here on the right-hand side, here in Saudi, 2/3 of the population are willing to receive healthcare through AI. Through their mobile phone, you can access your diagnostic report, you can have a clinical consultation, you can connect in with a doctor anywhere around the world. And so what we'd say to policymakers, and we've got quite a few policymakers and leaders in the room, your consumers in Saudi are very much up for this right now. They're willing for this. And the technology is here, as we've just heard from the previous.
And one interesting thing with this is, I think you would be surprised to find Nigeria so high on this list. But I actually recently hosted a roundtable discussion on AI and ethics. And it was actually attended by the Nigerian Minister for Communication and Information Technology. So very much as we see here today, the government and the policymakers getting engaged with these technologies is absolutely what will drive citizen adoption.
The other thing, to give you some encouragement, the UK is they were the lowest, and you would have thought the NHS has a fantastic reputation for universal health care. It's a long established health comparative benchmark. But we think here in Saudi, with your ambition, with the investment that's going in, you can leapfrog the UK. Because there's more politics in the UK system, there's more private practice, there's more complication we see. And as this is predicting, it's moving into smart health. A lot of governments, and including here in Saudi, you've done an e-health strategy. You started to implement change in primary health care and in medical cities and in hospitals. And you're starting to bring some of the technology. But the real smart element to this is actually getting to that predictive point where you as clinicians and administrators and leaders are having more time to work with your patients by using the best from the technology. A few practical examples. The Adar app, that's rated the world's #1 health Adar app. They were here in Saudi 2 weeks ago at the Future Investment Conference. 15 million users. You could download it today. It's powered by AI. It's a family medicine consultation anywhere around the world. Body Logical is a digital twin. So for chronic disease, and we have a lot of chronic disease, type 2 diabetes, for example, you can profile different eating habits, exercise, and stress and sleeping, and profile that through your digital twin to see the improvement, which helps with engagement and adoption of AI.
And in the first presentation, another example is the first presentation we saw a talk about the breast cancer and how the diagnosis is difficult. Well, a friend of mine started a company, Niramai, in India, and it's using AI and machine learning in order to detect breast cancer. But one step further than that, it's about changing the techniques as well. So developing techniques that are non-invasive, that have no radiation, and portable equipment that allow access then to their technology. And that was the point made earlier on. It's difficult to get to some of these areas, but using AI, machine learning, new capabilities, we can develop new techniques and bring medical treatments further out into more rural areas.
The economic impact is massive. So we've profiled the benefit to the economy here in Saudi by 2030. Over 12% of your GDP will be coming from artificial intelligence and adoption of that across all your services. And we think in healthcare there is literally a huge opportunity to probably leapfrog other health systems by adopting this. And we ourselves in our own company thought, we can't just let this happen to our leadership. We have to change the culture of our whole company. And we have said to everyone, we've got 6,000 staff, we've said to everyone, we want you to be curious about AI, we want you to learn about it yourselves, we don't want to push this to you. So everyone in our company has a digital fitness app, and they look at drone technology, they look at digital marketing, they look at AI, they look at virtual reality to spark that culture change. And you could have that in your own hospital systems so that your own people start to be curious about this and thinking about the potential.
I was very happy to see that I had a particularly high score in AI, which is good, made me feel really good about 20 years in AI.
That is good. Right, Scott, what do we actually mean by it and how do we start?
Thanks, Hamish. So one thing that also in the first presentation was talking about was breaking down AI, and that for me is critical in adopting AI, is trying to learn more about what it is. So a client may come to me in the past and say, I need AI. Yeah, but for what and what kind of AI? And exactly the same as you guys, we break it down into different ways that humans respond. So sensing, we talk a lot about data. Sensing in AI is the techniques that we use to collect the data. So this could be language. If you talk to an Alexa or a Siri, there's speech-to-text technologies, there's text understanding, natural language processing, my speciality. Then we generate the text, we might translate it into something, sentiment detection. All these are different types and applications of AI. Similar computer vision, there is so much in the medical domain in vision, in imaging. All the imaging technologies that we look at, that's computer vision and different applications therein. Then we need to think. Once we have all this data, it's all about thinking. And we talk then about machine learning or deep learning, neural networks, which are just a kind of machine learning. And many of the examples we've given, they're about leveraging a lot of data and a lot of different examples to learn and train a model so that we can then make a prediction one at a time, like what does your image tell us? But there are other use cases, this scale of AI and machine learning, and epidemiology is one. So there are a lot of studies at the moment of trying to understand how diseases spread. So using large amounts of data in order to track movements of a disease. And this is done a lot through social media and influenza, for example. Like Latin America, there'll be a study of looking at people tweeting to say, I feel really sick. I feel like I've got the flu. And using that to try and find patterns to see in what neighborhoods is this flu developing? Where is it spreading? Where is it going? Where did it start? So using these thinking techniques to then make sense of the data.
Next slide.
And then we act. So we then take those decisions. The other way to think about AI is that was what it is. This is how you might apply it. So there are two ways to look at applying AI. One is automation. And this is where we get very similar to robotic process automation and automation of just repetitive techniques. When we start talking about intelligent automation, it's the technologies we saw earlier on image processing. It's about being able to scale to look at thousands of images an hour rather than just 2. It's about taking a standard approach, and it's about standardizing. It's all about saving time. And this is really crucial in the medical domain. The other side is then the value add. How do we go beyond that? When I talk with more commercial customers, on the left it's about saving cost, and on the right it's about making money. In here, this is about adding to those moments of care. How can we generate more moments of care? And so we start talking about the personalized healthcare. How can we understand more about you as an individual so we can get one step beyond from that descriptive to the predictive analytics? How can we then get preventative healthcare because we understand more and start adding value to people's lives and medical professionals? We also touched earlier about the challenges to AI. And if I'm saying the same thing as said before, it was only because this is important. We mustn't let it stop us, but we have to acknowledge that there are some issues in AI. One very big one, and I don't know that there's a bigger domain than healthcare to apply it, is ethics. There's a lot of issues such as transparency of use of the data. What are you using it for? Whose data are you using? The Cambridge Analytica scandal of a couple of years ago, one of the reasons that was such a problem was they didn't tell everyone they were taking their data. So there's a lot of ethics in there.
Scott, in healthcare, because there's so much need for trust in actual consultation and delivery of healthcare, what would you advise health leaders around? Does this need someone at the board level who is an AI expert to help advise the executive team and then flow through the clinical governance? How do you get through this? Because I think if I was in the audience, I'd be thinking not just the Cambridge Analytica, I'd be thinking the US elections, I'd be thinking in the UK elections, the politics, geopolitics nature of AI. This can go wrong. There is also examples of a racist, Yahoo had a racist chatbot because the programmers didn't have the diversity in the coding. So all of these type of things have to be sort of implemented well.
Oh, 100%. And there's examples of bias in financial decision making where the bank will say, well, we took race out. We did not use race as data, but they didn't realize that by simply looking at this location versus that location, they were inadvertently using race because that's where people typically happen to live.
Yeah.
But you need the leadership to understand these concerns so that they can question them. So they can go in and have this intelligent conversation with the data scientists, because the data scientists like me, some of us may not care. We may just be building an algorithm. We just want to solve a problem. We want to make you more efficient. We may not think necessarily about how we're doing it. But when the leadership can then raise these questions and say, okay, what are you doing about bias? How are you treating this data? What governance have you got? How transparent can we be? Can we explain our decisions? That will then be crucial in developing that trust. Errors, though, that's actually related. You know, the error in predicting the finances, how you handle errors is very much related to that and is part of it. And one thing is about understanding the impact of the error. Now, a lot of AI will be applied in back office automation. So there's a lot of things that happen in our offices, in our finance departments, where if we make an error, it's no big deal. So if your algorithm is 80% accuracy, you're just not saving quite as much money. But again, we are in the most critical domain for errors. And understanding what type that you have is critical, because I saw one example. So again, breast cancer, it's a worse error to miss a case of breast cancer in a female than to overly suspect that a male has breast cancer. Just as a percentage, it happens, but it's less likely. So if you suggest a male has breast cancer, that's not great, and there is an emotional impact, but it's not nearly as critical as missing the error the other way. So again, understanding how the algorithms work and the techniques.
Now, there's lots of quite challenging statistics about replacement of jobs from AI, particularly in manufacturing and automation industries, and in healthcare. If colleagues are sitting in the audience and whatever generation they are, what would you say about workforce upskilling in healthcare?
I mean, it definitely connects to that leadership and everyone understanding more. But in terms of replacing the jobs, and there are a lot of scare tactics like this, and I saw one report in the UK a couple of years ago that doctors will be replaced because all they do is make decisions. Nurses will never be replaced because they're the human side, they're the care. I mean, that's really muddling the issues, but more recent studies are showing that a doctor may be, in a particular diagnosis, 92% accurate. The AI is 93% accurate. But when you actually combine the two decisions, they're 97% accurate. So what we're seeing more and more is we're not replacing people, we're not automating people, we're augmenting people. It's humans and technology together to make much better, much more informed decisions.
And let's be honest, the trust element and the final point of the consultation can never be replaced through AI in that respect. Just wanted to move into how we scale this. 3 quick lessons.
So this is really just a summary of what we just talked about. Essentially, the first thing to get involved is that learning piece. Yes, you need Python programmers at one end who can implement an algorithm. Nothing is off the shelf in AI. You need a lot of personalization, but it's more about the leadership learning and being able to question and understand and getting that strategy in place, that governance layer. Then piloting, starting small, because ultimately you need to get all your data and you need to do all these techniques, and it's going to cost millions, if not billions, to do the full end-to-end AI everywhere. So it's possible in businesses to identify few use cases. The back office is a typical place to start. Can we use some computer vision, some natural language document processing techniques to automate the processing of medical records? Kind of the digitization there. That's less risky than diagnosis. And once we see a return on investment in these small scale efforts, then we can convince the broader leadership team, the finances, that this is worth going into, because that's what you're going to need to then scale. Once you've brought everybody along and everybody understands and everybody's convinced that these technologies work, and you really do need to get your hands on them yourselves and see for yourself all these numbers that we all have to believe in them, because then you can scale and roll it out across your entire network.
Awesome. And there is a need for coherence in all of that strategy, because this is actually a fundamental human change going through. Now, what's holding us back? Why is there not much implementation of AI in this healthcare market right now? The technology's here, the investment appetite is here. Yep, no problem. But as I said, we do not want you as conventional healthcare, the long-standing operators in this health system, to be seeing your industry disrupted by those who have a stronger desire for bringing the technology to patients. Look at Kodak example, a very good, high-quality brand in film across the world. They miss digital. They miss digital in a big way. And we don't want healthcare to miss digital in a big way. And this is why there is a need for this coherence in the strategy and being very practical about the application and how you can benefit from it. And we think the best way to start to engage is make sure your clinicians are using technology around AI, because the clinical effectiveness is better, as we've heard in terms of some of the outcomes. So, the technology is here. This is not science fiction. The public are willing. You can look at our thought leadership on that from the survey of people here in the kingdom. You have a highly connected population. They're very active on Twitter, social media, smartphones. You as all leaders know this opportunity here. And just 2 weeks ago at the Future Investment Conference, it's just been announced that there is a national agency for AI, just started to be implemented. And it is going to come in a massive way. And you've got NEOM project, which is unbelievable. So
and Hamish, just to mirror your sharing a personal story,
yeah.
The reason I moved from Europe, many years in Europe and Australia and the US, to the Middle East is the National Centre for Artificial Intelligence. It's the Ministry for Artificial Intelligence in the UAE. It's the government's driving of AI that we may be behind in the region in adoption right now, but we're going to catch up so fast. And that was just incredibly exciting for me. So I love seeing these initiatives.
And this one's here in Saudi, just announced 2 weeks ago. Yeah, unbelievable. So we do think it's important to look at all of these elements. The leadership needs to be believing in it. It can't just be your data scientists in your hospitals going about and doing a novel project in AI. You will lose the return on investment. There was a very famous stockbroker in New York. He's been rated the #1 stockbroker in health for 5 years. And he said to me 2 weeks ago, guess how many venture capital requests he's reviewed in the last 5 years? Give me a number. 950. So he's reviewed 900, done due diligence on 950 cases. Do you know how many he's approved? 10. Well, but you were in the audience. Yeah, excellent. Yeah, 10. You guessed right. You guessed right. 10. So this just a little data point to say, yes, the technology is amazing. There's some clinical evidence to show it's better than humans. The public are willing, but it does cost money, and it does need that due diligence applied to it. And as the Ministry of Health moves into more of a regulator role, it will need to equip itself with AI specialists who can be ahead of the innovation and can help you in the health system really adopt this. So we hope this is helpful to sort of wrap up this session on AI, to really bring it together. You've heard some practical examples. It's fantastic that you have a command center here in Riyadh. Well done to GE and Ascend. And you've got committed leaders to really transform, and we look forward to your questions. Thank you.
Thank you.
It's your turn now.
Thank you very much. It was a very nice presentation. We have only 5 minutes for the question and answer, please. And this is my team here today. Before you ask us, I have one question for you. What do you think about AI? It's going to affect our health system positively or negatively? Please. Positively. 100%? Okay. There is no mic for the audience. There is no mic for the audience. Please. You can use the mic.
Yes, of course, it's positively, because we have a lot of examples. We know it and we hear it and we are use it. like any devices we are using it in any heart diseases, for example. This is a very famous example.
Yeah, it's in everyday life.
Yes, so it's positively, yes.
Yeah.
Thanks.
Any question? Any question from the audience?
Okay, assalamu alaikum. My question to Ms. Molly, I'm Majda Shukdar from Sebahi, which is the National Accreditation Program. You mentioned one of the things regarding the diagnostic, especially with the pathology diagnosis. Part of our actually requirement is to ensure the credentialing and the privileges of those healthcare providers. So from the slides from the Joint Commission, what was the tool that they are using to verify the credentialing of the people or whomever is behind this diagnosis? And I think this is one of the reasons if you see the variation between Nigeria and UK regarding the readiness to accept the AI. Is this part of the mistrust, or what was the reason?
Thank you. So I think I'm hearing you say, how do they get to the credentialing of laboratory diagnosis,
yes.
right? So, well, particularly for the command centre, it won't make a diagnosis for a doctor. So it's a clinical decision support tool, but it will not give a diagnosis. So it will flag up laboratory results which are off, which are too high or too low, and at the same time the patient already has a diagnosis in the system which conflicts with the laboratory results, which enables the clinician to go back in and reassess or ask for another set of laboratory results or go to another test. Does that make sense? So it won't provide a diagnosis. It will give you indicators as to how you need to now explore the next steps in the care pathway.
How can I ensure that actually this is like, as you mentioned, 100% the right diagnosis? I mean that when you have people that you can talk to them, you can just even discuss this with, it's a diagnosis that will decide the plan for the care later on. And we have many of errors happen because of this misdiagnosis happen sometimes. So what will be the quality control for such a tool or electronic process?
I can see Hamish ready to jump in and say, but I would say firstly, I'm just reiterating what Dr. Scott was saying about the accuracy of artificial intelligence. So part of the program of setting these things up is a very, very long validation, staging and testing process. And that is continuous. So we have very rigorous clinical committees who oversee the results that come out. And what the idea with machine learning is if it gets it wrong, if it predicts wrongly, it learns. So every day that accuracy, it gets better and better in terms of the prediction it can make. But it has to have the human interaction to say, no, that was wrong that time, or that doesn't quite look right, or actually the laboratory test that was ordered should never have been ordered anyway. So that's why we say the human interaction is so important, and we go through a very long staging process before these things go live.
Just quickly. There is a gold standard for the quality of data for AI. And in your role as regulators, I think you should always be looking to have that gold standard. It takes some time for the AI to get to that point. There have been some scandals in healthcare as well as other industries where it hasn't got to that standard. So this is part of the role that regulators practically play to help.
Any question? Yes, please.
Yes, I do not have a question, but I have a comment on Dr. Scott and Mr. Clark's presentation. We cannot get to the end point before getting started, and fearing the errors and fearing missing out or doing something wrong will not get you to the end point. So start before getting disrupted. Or as the famous sentence, disrupt or get disrupted. Yes. So we have to move on. We have to get started with AI. We have to implement and adopt these emerging technologies before and control the effect before getting controlled by the effect.
Alhamdulillah. Alhamdulillah. Agree completely. That's exactly right. But we don't want, given the amount of change that's happening, the positive change that's happening in Saudi across all the health sector, we think the technology side is an area that can be more prominent. And you do have to make a start. You do have to have leadership that buys into it. You do have to have regulators that will support this. And the clinicians need to believe it. And you're going to learn as you go as well, for sure. This can't just be we rely on the AI and then we don't make the change. It's got to be continuous. Agreed, alhamdulillah.
Any more question? I have one question for you. What's the relationship between augmented reality and artificial intelligence? How it can?
Yeah. In terms of the experience?
Yeah, I can talk about it.
Yes, in terms of AI, yeah.
So, augmented reality is a technology that lets you see and visualize data. So, I could have an augmented reality headset on, I could see Hamish, but I have his X-ray in my eye view. Where you plug in AI is that the X-ray is then highlighted, as we saw in the first generation. We could see the X-ray, that's just augmented reality. If we then have the highlighted area where AI has predicted, then we're adding the two together. So they're very much related. It's about applying one to view the other.
شكرا جزيلا على حسن الاستماع، وإن شاء الله نلتقي في إن شاء الله لقاءات أخرى بإذن الله.